Hi everyone, I am going to review page 280 in your book, numbers 1, 4 to 6, 7 to 9, 11 and 19 odd. Okay, number 1 is asking us to match the trig function with its right triangle definition. So letter A is sine. If you refer back to SOHCAHTOA, remember that sine is always opposite over hypotenuse, okay, which is number 3. So letter A's answer should have been 3. Okay, opposite over hypotenuse. So I'll cross that one off. Letter B, cosine, goes with ca. So adjacent over hypotenuse. Okay, which is right here. Number 6. Okay, so that's what our letter B is matching with. Letter C is tangent. Okay, tangent is TOA. So opposite over adjacent, which is number 2. Okay, cosecant. So now you want to remember what trig function goes with the reciprocal of these. So cosecant is the reciprocal of sine. So you're just going to flip it. Okay, instead of opposite over hypotenuse, it's hypotenuse over opposite, which is number 5. Letter E, which is secant, okay, is the reciprocal of cosine. So I'm going to put cosine above it. So secant is hypotenuse over adjacent, which is number 1. And then lastly, cotangent is the reciprocal of tangent. Okay, so it's going to be adjacent over hypotenuse. Okay, so number 4. Okay, number 4 in the homework, actually 4 through 6 I should say, says use the figure to the right to answer the questions. Okay, so number 4, what is the length of the opposite side of angle theta? So looking at angle theta, okay, the side opposite is 5. Okay, and if you need to label those, that's fine. Number 5 asks, what length is adjacent to theta? Remember, adjacent is right next to, so the 12 is right next to theta. Number 6 is asking what the hypotenuse is. The hypotenuse is always across from the right angle, so the hypotenuse is 13. Okay, so those should have been pretty easy. You were not calculating anything. All right, numbers 7, 8, and 9, basically they just want us to find the exact values of the 6 trig functions of theta. And remember, we want to leave our answer exact, okay, so we're going to keep it in fraction form. If you end up having a radical, you're going to keep that there. Do not change it to a decimal. Okay, so let me zoom in here on number 7. We'll start there. Okay, the first thing that we want to do is use Pythagorean theorem to find the missing side. So I'll go through that kind of quickly, but we're looking for this side here. Okay, so you have, and I'll put here, this is our step 1. You have the hypotenuse, which is 41. So we have 41 squared equals, we're going to look for this side that's missing, which is A. Okay, we're going to add on the other leg. So 41 squared is 1681. Okay, you have a squared plus 81. And then to solve that, subtract your 81 on both sides, and then take the square root of 1600. So your missing side ends up being 40. So I'm going to put in here a equals 40. So our 3 sides that we're using to set up our 6 trig ratios are 40, 41, and 9. Okay, so your step 2 is to write all those down. Okay, so I think the easiest way is, when I presented the notes for this, start with your sine theta, okay, and you know the reciprocal of that is going to be cosecant theta. And then we're going to go to cosine theta. We know the reciprocal of that is secant theta. And then lastly, we're going to do tangent theta. We know the reciprocal of that is cotangent theta. Okay? So going back to sine, Okay, sine theta, and remember, always go back with your theta, which is right here. Okay, the opposite of that is 9. The hypotenuse is 41. So 9 over 41. The cosecant is the reciprocal of sine. So that's going to be 41 over 9. Cosine is adjacent over hypotenuse. So the adjacent side is 40. The hypotenuse is 41. Secant is the reciprocal of cosine. So you're just going to take the reciprocal. So it's going to be 41 over 40. Okay, remember, same thing as hypotenuse over adjacent. Tangent is opposite, which is 9, over adjacent, which is 40. Cotangent is just the reciprocal of that. So flip that, 40 over 9. Okay, so that's your solution for number 7. All right, number 8 is going to be very similar. And again, we're finding exact values, so you want to make sure that you are keeping your answers in fractions, or if there is a radical, we'll keep that square root there. Okay, so our first step on 8 is we're going to use Pythagorean theorem. I'm going to label this B, but it doesn't matter. We're going to use Pythagorean theorem to find the missing side. So remember, c squared equals a squared plus b squared. So 13 squared equals 5 squared plus b squared. So 169 equals 25 plus b squared. Subtract your 25. So we have b is 12. So I'm going to fill that in. So the three sides we're using are 5, 12, and 13. Once you have your sides, that's easy to set up your ratios. So we'll come, I'm going to go over here. So step 2. Okay, and I'm going to start with sine again, just to be consistent. Sine of theta is opposite over hypotenuse. Again, we're looking from theta. So opposite is 5. Hypotenuse is 13. The cosecant of theta is the reciprocal of sine. So it's just going to be hypotenuse over opposite. So 13 over 5. Let's now find cosine theta, which is adjacent, which is 12, over hypotenuse, which is 13. The reciprocal of cosine is secant. So just going to be hypotenuse over adjacent, or 13 over 12. Tangent theta is opposite, which is 5, over hypotenuse. I'm sorry, opposite over adjacent, so 5 over 12. And then cotangent theta is just the reciprocal of that, which is adjacent over opposite. Remember, that's TOA. Okay, so that's number 8. Let's now look at number 9. Okay, so number 9, our missing side is now the hypotenuse. Okay, so we want to find our hypotenuse first before we can set up our 6 trig ratios. All right, so step 1, we're taking c squared equals 15 squared plus 8 squared. Okay, 15 squared is 225. 8 squared is 64. So add those, you get 289. And then the square root of that is 17. So the hypotenuse is 17. Okay, so for step 2, we now have all of our sides. We can now set up our 6 trig ratios. So sine theta, again, using theta as your reference angle. Opposite is 8 over hypotenuse is 17. Cosecant theta is just the reciprocal of that, so 17 over 8. Cosine theta is going to be adjacent, which is 15, over hypotenuse, which is 17. Secant theta is the reciprocal of cosine, so 17 over 15. Tangent theta is opposite over adjacent, so 8 over 15. Cotangent theta is just the reciprocal of that, so 15 over 8. Okay, our next one is 11. Okay, So number 11 says find the exact values of the 6 trig functions of angle theta for each triangle. Explain why the function values are the same. Okay, so let's first start by taking the larger triangle, okay, and let's find the side that's missing. All right, so right here. All right, so we have our hypotenuse, which is 10. So 10 squared equals, all right, our sides are 8 squared, and we need to find the other one, which I'm going to call b. Okay, so we have 100 equals 64 plus b squared. When you subtract that, you get 36. So the square root of 36 is 6. Okay, so on this one, we end up with this side is 6. Okay, so if we look at the smaller triangle to the larger, and I'm not going to do the work for the little one here, because these triangles are similar, okay, their corresponding sides are going to be proportional. All you have to do to go from the small triangle to the big one is multiply all the sides by 4. Okay, this side would be 3 over 2. Okay, that 2.5 is just 5 over 2 on the small one. So again, if we were to set up all 6 trig ratios for the big one and the small one, they reduce to be the exact same fraction. Okay, so any similar triangle, any set of triangles that are similar, their sides are always going to be proportional. They are going to reduce to the same fraction. Okay, so if you did set those up for the small one, the solutions are the same as I'm going to list for the bigger one here. Okay? All right, so we'll start with our sine again. Okay, so for both triangles, the sine theta is 6 over 10, which reduces to 3 over 5. Cosecant theta is the reciprocal. So if we flip that, you end up with 5 over 3. Okay, so again, that's for both triangles. Cosine theta is adjacent, which is 8, over hypotenuse, which is 10. That reduces to 4/5. The reciprocal of that is secant theta. So you just want to take the reciprocal, flip that around. Tangent theta is opposite over adjacent, so 3/4. Okay, cotangent theta is just a reciprocal, so flip it. Okay, and again, those trig ratios are the exact same for both triangles because they are similar triangles. Okay, number 13. Okay, actually for 13 through 19, we're going to sketch the right triangle and then use Pythagorean theorem to find the third side, and then we're going to find the 5 other trig functions. So I'm going to do 13 up here. Okay, so I'm going to sketch a triangle first. I'll put theta here. Okay, so we know for 13 that sine theta is opposite, which is 5, over hypotenuse, which is 6. Okay, we need to find the missing side length, which I will call b. So the first thing you're going to do is use your Pythagorean theorem. 6 squared equals 5 squared plus b squared. Okay, so when you subtract, you end up with 11. So b ends up being the square root of 11 in this one. Okay, so it's okay to have an irrational number. Remember, you want to keep your answers exact when we're setting up our trig ratios. Okay, so they already gave us sine theta, so let's start with cosecant theta, which is just the reciprocal of that, so it would be 6 over 5. Cosine theta is adjacent over hypotenuse. Okay, the reciprocal of that is secant theta, which is 6 over square root 11. We need to multiply the top and bottom by square root of 11. Let's see if I can fit that. To rationalize the denominator. So you'd have 6 square root of 11 over 11 for your secant theta. Tangent theta is opposite over adjacent. So 5 over square root 11. Again, multiply the top and bottom by square root 11 to rationalize your denominator. So 5 square root 11 over 11. Cotangent theta is just the reciprocal of that. So if you go back to the original fraction over here from tangent, it'd be square root of 11 over 5. Okay, sorry, that's a little bit messy. Number 15. Okay, we have secant theta is 4. So let me write that here. And I'm actually going to put 4 over 1, just so it's easier for you to write down the sides. Secant is the reciprocal of cosine. So this is really our hypotenuse. This is our adjacent. So let's sketch a triangle. Okay, our hypotenuse is 4, adjacent is 1. Make sure you have your right angle in there. So when you use Pythagorean's theorem, we have 4 squared equals 1 squared plus b squared. When you solve that, you end up with b is the square root of 15. Okay, so I'm going to put this as square root of 15. So finding our other 5 trig functions, because they gave us secant already. Okay, so let's start with cosine. So your cosine theta would be 1 over 4. Let's now jump to sine theta, which is opposite, square root 15, over hypotenuse. The reciprocal of that is cosecant. Okay, so if you flip that, we have 4 over square root 15. Rationalize your denominator, so multiply the top and bottom by square root of 15. So you end up with 4 square root 15 over 15. Okay. All right, tangent and cotangent. So tangent theta is square root 15 over 1. And then the reciprocal of that is cotangent. So take the reciprocal, we have 1 over square root 15. Multiply the top and bottom by square root 15, so you have square root 15 over 15. Okay? So that's 15. All right, let me get myself more room here. Let's go over 17 and 19, and then hopefully, if this isn't already easy for you, that this helps. Okay. All right, so 16, or not, sorry, not 16, 17. They give us tangent theta equals 3. Okay, and we're going to find the 5 other trig functions. Make it 3 over 1. Okay, and we'll put theta here. So we have opposite over adjacent, which is, we have our 3 and our 1. We're going to find the hypotenuse. So we're going to set this up as c squared equals 3 squared plus 1 squared. Okay, so you end up with c squared equals 10. C is the square root of 10. Okay. Once you have all your sides, we're going to, again, find our other 5 trig functions. Since they gave us tangent, let's just start with cotangent. Easy enough to flip that around. So cotangent theta is 1/3. Let's now find sine theta, which is opposite. Oops, not square root. Opposite, which is 3, over hypotenuse, which is square root 10. Multiply the top and bottom by square root 10. So you end up with 3 square root 10 over 10. Okay. The reciprocal of sine theta is cosecant theta. So you're going to take the reciprocal of that, the square root 10 over 3. Always go back to that original fraction. Cosine theta is adjacent over hypotenuse. So again, rationalize that denominator. Multiply the top and bottom by square root 10. So you have square root 10 over 10. The reciprocal of that is secant. So secant theta, go back to your original fraction. and take the reciprocal. So square root 10 over 1. If you leave it as square root of 10, that's fine. Okay, last one, number 19. They gave us on 19, cotangent theta is 3 over 2. We know cotangent theta is the reciprocal of tangent, so this is really our adjacent side. This is our opposite side. So let's draw our triangle. Okay, so adjacent is 3, opposite's 2. Okay, we're going to find our hypotenuse. So when you use Pythagorean theorem, 2 squared plus 3 squared equals c squared. 4 plus 9 equals c squared. So c is the square root of 13. Okay, we already have cotangent, so to find your other 5 trig ratios, I would start with your tangent theta, take the reciprocal, so you get 2 over 3. All right, I'm going to come down here. Let's find sine theta, which is opposite, which is 2, over hypotenuse, which is 13. Multiply the top and bottom by square root 13. So 2 square root 13 over 13 is your sine theta. The reciprocal of that is cosecant theta. Okay, so you have square root 13 over 2. Again, just take the reciprocal of sine. Cosine theta is adjacent over hypotenuse. Multiply the top and bottom by square root 13. So you get 3 square root 13 over 13. Secant theta, take the reciprocal of cosine theta. So square root 13 over 3. Okay. All right, so that is the end of page 280 in your book. If you have additional questions, please email your teacher. And hope everyone's doing well. Stay safe and healthy, guys.